Okay, so this is learning target 6. We're going to be writing in factored form. So far we've worked with vertex form. That was last week, and then a little bit on Monday. Remember, with vertex form, we can see the a value. We need to identify the a value, and then also the vertex, which in this case is the h and the k. So remember, vertex form, we need the a value, which remember is half that second change. And we also can identify, or we need, the vertex if we're trying to write the equation in vertex form. All right, so today we're going to be looking at factored form. In factored form, you can see we also need, or it identifies the a value as well. You can see that right here. So we're going to need that as well. And then we also, not the vertex, these are actually the solutions to the quadratic function. And so that's why we see S1 and S2. Those are not 5s, those are S's. So we'll look at that here in this one, and then standard form, that will be later. So we're not going to be doing that one today. Today will be factored form. All right, so if you remember solutions, what are solutions to quadratic functions? Solutions are where the quadratic touches the x-axis. It's the x-intercept, right? Otherwise known as the zeros. So looking at a graph here, remember our x-intercepts are where our y value is always 0, right? So our output would always be 0. So looking at a table, we can usually spot them pretty quick, just by, if they're there, if they're listed. And in this case, they are. So we can see our two solutions right here. We would say our solutions are at x equals 2 and also x equals 4. So that's the first piece of information we need to write in factored form. And then the second would be the a value. So we're going to go ahead and get that change. So this is going down 3, down 1. It's going back up 1, going up 3, and going up 5. So it appears that our second change is doing what? It looks like it's going up by 2 each time. All right, so if our second change is 2, then we know our a value is half of that, which is 1. All right, so now we have the information we need to write this in factored form. All right. So a value 1. And now we're going to write our two solutions here. All right, so if you remember up here, this is x minus and x minus, just like this one up here. So remember that this would mean it's the opposite of whatever that number is. And I'll show you another way to think about it too, if that's not working for you. So our first solution here would be 2. So instead of writing this as x minus 2, this would be x. Actually, it is x minus 2. And then our second one would be x minus 4. All right, so a way that you can think about it, and I know sometimes you think, okay, opposite, what do you mean? When do I put plus, when do I put? One way you can think about it is what number that you would plug in for x would turn this entire output into 0. Well, one number you could put in is a 2, right? Because 1 multiplied by 0, right? 2 subtract 2, multiplied by, it doesn't matter whatever it is, because 0 multiplied by anything is always this. A 2 here will make this entire output 0, and a 4 will make this entire output 0. And so we can see that holds true to our table right there. So that's one way you can think about it if you're confused about the positive, negative. Do you guys see the vertex here? This one actually also shows the vertex. So we could write this in vertex form also if we wanted to. And just a little review, might as well. Remember, vertex form, we need the a value, which we already have. It's right there. And x minus, our vertex is right here. And remember, our vertex, we can see the symmetry around it, surrounding it. We can see that this is going to be a minimum point because it's the lowest possible output compared to everything else in the table. All right, so our vertex here would be 3, negative 1. So this would be 3. And then can't forget the squared there, and then plus a -1, or you could just write subtract 1. Either way would be fine. All right, so this table you could actually pick and choose which way you wanted to write. You could write vertex or factored form. These are actually equivalent to each other. All right, so why don't you guys go ahead and try an example. Why don't you try writing this in factored form. So you could pause the video and go ahead and try that on your own. All right, so factored form, we need our a value. And to get our a value, we're going to get our first and second change. Doesn't change at all there. And then it goes back up 6. So looks like this one is increasing by 6 each time for the second change. So if our second change is 6, then our a value would be 3, half of that. All right. And our solutions, we can see a solution right here. We can also see a solution right here. This is when my outputs are 0. This would not be a solution. This would be known as a y-intercept. It's where the quadratic hits the y-axis, and solutions are just the x-intercepts. All right, so vectored form. A value is 3. All right, and here's where that opposite thing happens, and we'll check it with that way I showed up in the previous one to make sure we've got it right. So remember, the generic form is x minus S1 and x minus S2. So since our solutions in this case are -1 and +2, this would be +1, and this would be subtract 2. And a good way to check to make sure that you've got it correct, remember, what's the only value, well, what's the value for this note, for this x, that would make this entire output 0? Remember, we would just want to make this 0, so -1 would work, and that's right there. And then what's the other possible value for x that would make this entire output 0? If we plugged in a 2 for x, then this entire output would be 0. We can see that matches the table right there. All right, so that is factored form. Try the practice. Thanks, guys.